start with the next exercise of permutation and combinations. The next exercise is based on permutations with repetitions. Now let us see the theorem. What is the theorem based on permutations with repetitions? The number of permutations of n different objects taken r at a time. The number of permutations of n different objects taken r at a time where repetition is allowed is n power r. The theorem is the number of permutations of n different objects taken r at a time where repetition is allowed. Now here repetition is allowed to us, so the number of cases will be n power r. Let us take an example. Suppose we have 5 objects. Suppose we have 5 objects and we have 3 vacant places. Now these 5 objects are to be arranged at 3 vacant places and repetition is allowed to us. So students, this place can be filled up in 5 ways. So this first place can be filled up in 5 ways by the any one of the 5 objects. Now this second place can be filled up again in 5 ways because repetition is allowed. So this second place can be filled up in 5 ways, and similarly this third place can be filled up in 5 ways. Right students? So total number of ways. So total number of ways is 5 power 3. So this is equal to 125. So therefore number of permutations of 5 different objects taken 3 at a time. So number of permutations of 5 different objects taken 3 at a time where repetition is allowed is equal to 5 power 3, because we have 5 objects and we want to arrange them 3 at a time. So 5 power 3 equals to 125. Repetition is allowed. So students, the answer will be 5 power 3. And there is a second theorem, permutations of objects not all different. Now students, the next theorem, permutation of objects not all different. Now according to this theorem, the number of permutations of n objects taken all at a time when p objects are alike and of one kind, q objects are alike and of another kind, and r objects are alike of yet another kind, and remaining objects are different, then the number of permutations is equal to n factorial upon p factorial into q factorial into r factorial. I repeat the theorem again, then we take example to understand this. The number of permutations of n different objects taken all at a time when p objects are alike and of one kind, q objects are alike and of another kind, and r objects are alike of yet another kind, and the remaining objects are different, is given by n factorial upon p factorial into q factorial into r factorial. Now students, let us take an example. Now students, let us take an example to understand this theorem, that how many different words can be formed with the word Allahabad. A double L A H A B A D, Allahabad. How many different words can be formed with the word Allahabad? Now students, you can see here total number of letters. Total number of letters 1, 2, 3, 4, 5, 6, 7, 8, 9. Total number of letters 9, in which A is coming 4 times, L is coming 2 times, right? And then H is coming 1 time, B is coming 1 time, and D is 1 time. So total are 9 letters. Now, so number of different words that can be formed. So here A is coming 4 times and L is coming 2 times. So according to this theorem, total letters are 9. So we write 9 factorial, and in the denominator we write the letters which are repeating. So A is coming 4 times. So we write 4 factorial. L is coming 2 times. So we write 2 factorial, like this. So total letters is 9. So we write 9 factorial in the numerator. अपॉन में हमारे पास वो आते हैं जो लेटर्स हमारे रिपीट कर रहे हैं. So A is coming 4 times. So we write 4 factorial into L is coming 2 times. We write 2 factorial. So on solving it, we get 5760. So these are the total number of words that can be formed with the word Allahabad. Now students, let us start with the first question of exercise 6.5. In how many ways can 5 apples be distributed among 4 boys, there being no restriction to the number of apples each boy may get? Now students, we have number of apples 5 and apples to be distributed among 4 boys. So suppose this is boy 1, boy 2, boy 3 and 4th boy. Now first apple can be given to in 4 ways. जो first apple है हम वो किसी भी boy को दे सकते हैं. So first apple can be given in 4 ways. So first apple can be given in 4 ways, because that apple can go to boy, first boy, second boy, third boy or fourth boy. Similarly, second apple can be distributed among in 4 ways, because there is no restriction to the number of apple each boy may get. Similarly, the third apple may be given in 4 ways again, and fourth apple may be given again in 4 ways, and fifth again can be given in ways. So therefore, total number of ways, this is equal to 4 into 4 into 4 into 4 into 4 equals to 4 power 5. So the answer is 4 power 5. So number of ways in which 5 apples can be distributed among 4 boys equals to 4 power 5. Now second question. So I hope student this is clear to you. Then in how many ways 4 prizes to be given to 3 boys? So we have 4 prizes and 3 boys. So students, first prize can be given in how many ways? 3 ways. Can be given in 3 ways, because first prize can go to either first boy, second boy or third boy. So first prize can be given in 3 ways. Then second prize can be given in 3 ways, and third prize can be given again in 3 ways. Why 3 ways? Because when a boy is eligible for all the prizes. So here repetition is allowed according to this. So fourth prize can be given in 3 ways. I read the question again. In how many ways can 4 prizes be given to 3 boys when a boy is eligible for all the prizes? यानी इस केस में ऐसा भी हो सकता है कि सारे प्राइजेस एक बच्चे को मिल जाएं. ये केस भी पॉसिबल है. So first prize can be given in 3 ways. Second prize again can be given in 3 ways, because that prize can be goes to B1, B2 or B3. Third prize again 3 ways, because third prize can also go to B1, B2, B3, and fourth prize can be given in 3 ways. So total number of ways. So total number of ways is equal to 3 into 3 into 3 into 3 equals to 3 power 4. So therefore, number of ways in which 4 prizes can be given to 3 boys is equal to 3 power 4, and 3 power 4 is equal to 81. Now the next question is, students, number third, a boy has three pockets. Number third question, a boy has three pockets, P1, P2 and P3, and in how many ways can he put six marbles in his pocket? So students, we can write each of the marble, or we can write first marble can be put in any of the three pockets in three ways. So first marble can be put in any of the three pockets in three ways. Similarly, second marble can be put in three ways, because we can put all the marbles in one pocket also, or we can say repetition is allowed. So third marble can be put in three ways, and fourth can be put in three ways, and fifth marble can be put again in three ways, and then sixth marble can be put in three ways. So therefore, total number of ways. So total number of ways equals to 3 into 3 into 3. So this is equal to 3 power 6, and this is equal to 7 to 9. So total number of ways in which a, uh, a boy can put six marbles in his pocket. Now students, sum number 4, a letter lock consists of four rings, each marked with six different letters, and in how many ways it is possible to make an unsuccessful attempt to open the lock. It is possible to make an unsuccessful attempt to open the lock. Now students, here we are given four rings. हमारे पास four rings हैं, R1, R2, R3 and R4, and each marked with six different letters. Each ring is marked with six different letters. In how many ways it is possible to make unsuccessful attempts to open the lock? Now students, each ring is marked with six different letters. So this ring R1 can be filled up any one of the six letters. So R1 can be filled up in six ways by any one of the six letters. Similarly, R2 can be filled up in six ways by any one of the six letters. Similarly, ring R3 can be filled up in six ways by any one of the six letters, and R4 can be filled up by any one of the six letters. So students, total number of arrangements. So total number of arrangements. Total number of arrangements will be of these letters is equal to 6 power 4. 6 into 6 into 6, 6 power 4. Out of these, only one is successful attempt. हमारे पास टोटल अरेंजमेंट्स बने हैं 6 पावर 4, और उसमें से हमारे पास एक अटेम्प्ट ऐसा होगा जो सक्सेसफुल होगा, मींस उससे जो हमारा लॉक है वो ओपन हो जाएगा. सो स्टूडेंट्स, one is successful attempt and rest are unsuccessful. सो देयरफॉर टोटल नंबर ऑफ हमने फाइंड करने हैं अनसक्सेसफुल. सो टोटल नंबर ऑफ अनसक्सेसफुल अटेम्प्ट्स इक्वल टू 6 पावर 4 हमारे सारे टोटल हैं -1. सो 6 पावर 4 is 1296 -1, so 1295. So we have 1295 are the unsuccessful attempts. So students, I hope this is clear to you. Now let us start with the fifth question. Students, question is, there are three identical blue balls. We have three identical blue balls. Then we have four identical red balls, right? And we have five green balls. So students, in how many ways can they be arranged in a row? So students, we have total number of balls. Total balls are 3 plus 4 plus 5 equal to 12. So number of ways in which the balls can be arranged in a row. So we use second theorem. Total balls are 12, 12 factorial upon 3 are blue identical balls, 3 factorial, 4 are red identical balls, and 5 are green identical balls. So we write 12 factorial upon 3 factorial, 4 factorial, and 5 factorial. On solving it, we get 27720. We can solve it with the help of calculator. Now let us see some number 6 question students. Number 6. Now in the sixth question, how many two-digit numbers less than 100 can be formed with the digits with the digits 1, 3, 5, 7, 9, with the digits 1, 3, 5, 7, and 9, and we want to make a two-digit number when the digits may be repeated. Digits may be repeated. Digits may be repeated. So students, here we want to make a two-digit number and digits may be repeated. So students, this is the unit place and this is the tenth place. So unit place can be filled up in 5 ways by any one of the digits 1, 3, 5, 7, 9. So unit place can be filled up in 5 ways, and tenth place digit. Now 10th place digit can be filled up in 5 ways again because repetition is allowed. So 10th place can be filled up in 5 ways. So total number of two-digit numbers. Total number of two-digit numbers that can be formed with 13579 is equal to 5 into 5 equals to 25. So these are the total numbers that can be formed, two-digit numbers with the digits 13579 when digits may be repeated equal to 25. Now stand seventh question, how many four-digit numbers can be formed with the digits 1, 2, 3, 4, 5, 6 when a digit may be repeated any number of times in any arrangement. So students, we want to make a four-digit number in this question, four-digit number, and digits that are to be used are 1, 2, 3, 4, 5, 6, and digits may repeat. So students, here we want to make a four-digit number. Now students, the unit place, this is unit place, this is 10th place, this is 100 place, and this is 1000 place. Now unit place can be filled up in 6 ways by any one of the digit 1, 2, 3, 4, 5, 6. and because repetition is allowed, so 10th place again can be filled up in 6 ways, 100 place can be filled up in 6 ways, and 1000 place can be filled up in 6 ways. So total number of 4 digit numbers, total number of 4 digit numbers is equal to 6 into 6 into 6 into 6 equal to 6 power 4, and this is equal to 1296. So total number of 4 digit numbers that can be formed by using the digits 1, 2, 3, 4, 5, 6 when repetition of digits is allowed is equal to 1296. Now number 8 question, how many 3 digit numbers can be formed by using the digits 0, 1, 3, 5, 7 when the digits may be repeated any number of times. So here students, we want to make a 3 digit number. 3 digit number is to be formed, and we have to use the digits 0, 1, 3, 5 and 7. So here are the 3 digit numbers. Now students, this is the unit place, this is the 10th place, and this is the 100 place, right? Now students, 100 place cannot be filled up by 0, because if 100 place is filled up by 0, then it becomes 2 digit number. So 100 place can be filled up in 4 ways, either by 1, 3, 5 or 7, not by 0, not by 0. So 100 place can be filled up in 4 ways, either by 1, 3, 5 or 7, not by 0. And 10th place can be filled up in 5 ways because repetition is allowed. So 10th place can be filled up in 5 ways by any one of the digits 0, 1, 3, 5, 7, and unit place can be filled up in 5 ways by any one of the digits 0, 1, 3, 5, 7. So total number of 3 digit number, total number of 3 digit numbers are, so 4 into 5 into 5 equal to 100. So students, these are the possible numbers, 3 digit numbers that can be formed by using the digits 0, 1, 3, 5, 7 when repetition of digits is allowed. Now students, the remaining questions will be discussed in the next video. Thank you.